Hey guys, this is Jerry Stone. I'm back with a new video, which is apparently a rarity now because I've just been too busy. So with that, I would like to say that, yeah, I'm not going to be able to upload very often, but I'll see what I can do. I've gotten a lot of cool radios, it's just fixing them is time consuming, and there is a reason why most people who work on radios are retired. Anyway, today I have a little bit of time. So we're going to work on this, what model is this? This Emerson 561 Series B radio. I got this as part of like a recent Craigslist deal for radios. This was one of them for $60. Oh man, I really like the Bakelite and the back painted plastic. It's a good combination. I shined up the cabinet. But I have not electrically restored it. I took a quick look inside, everything looks to be there, so this will be a good candidate for hopefully a quick restoration. It looks like a pretty common series strung 6-tube chassis, so maybe a little bit more sensitive. Another thing that's interesting is that the chassis comes out from the bottom instead of the back, so visually the design of the radio is not interrupted as you go around the back. So this would have been good to like put in the middle of a table instead of backing it up against the wall. Just a little bit of something to think about. Speaking about retired people, so a bit of a talk before we start this. I'm a member of the Colorado Radio Collectors Club, and I am by far the youngest member. And what they would like me to do, and what I have been doing to at least some capacity, is I'm trying to see if there's anyone younger who is interested in the hobby, because it's really hard to get younger people interested in the hobby for one reason or another. I'm hoping my YouTube channel can help to be it can help maybe motivate someone who's on the fence about it. I really recommend it. It's a fun hobby, and although the devices you work on may not use the most modern designs, and maybe you won't employ the most modern techniques to fix them, the skills I've learned, the troubleshooting, and just the identification of just electronic components and functions, that is certainly helpful, especially if you want to pursue something like electrical engineering. A capacitor has not changed over the last 100 years. It still has the same function, and radios are still used everywhere. Anything that uses a wireless design, so like Bluetooth or Wi-Fi or whatever, that's still a radio. That's a wireless circuit. And although these are much simpler devices, they're still very similar fundamental principles. So yeah, I think it's a valuable hobby to get into, and I encourage you to reach out to your local club. For most of the, I can't speak outside of the United States, but for most of the states there is a club. I know in Colorado there's one, although I usually have to drive a bit to go to their meetings. But I encourage you to reach out. The clubs, I promise you, they're looking for younger members, so I think it'd be really valuable. If there's any younger people watching, I think that would be meaningful. So with that rant out of the way, I'm gonna get started on this. All right, here's a closer look at our set here. Again, very nice Emerson. Emerson, you know, a lot of people talk about, you know, the gorgeous like black dial zeniths and other Art Deco like majestic smart sets from the early 30s, but Emerson also did a lot of really interesting designs with their radios, and this is no exception. This is very, very nice. Yeah, I mean, I already showed you it. So yeah, if we look on the bottom, this is actually where the chassis is going to come out. So we can get started by pulling off the knobs. Don't need it with this radio, but a trick I often employ is if the knobs are stuck, I would not ever. Something that I definitely do not recommend is to get a screwdriver and pry them out. What I do is I get a good towel and wrap it behind the knob and yank on it. And the only radio I haven't had that work on is this like the Zenith black dial with those plastic Z knobs that actually shrink. I don't think I'm going to be able to get that apart without destroying the knobs. But on every other set I've had that work, so I recommend that. It's interesting these have adjustable feet on the front, but actually hidden behind is a flathead screw, so we'll pull that out. Okay. Here we go. If we zoom in a bit, we can take a look at our chassis. Here's your tuning capacitor. This is very dusty. 1, 2, 3, 4, 5, 6. 3 of the tubes are octal GTs, 3 of them are miniatures. Now, every single video, my can of compressed air runs out, so I end up doing like the most backwards way. I'm not going to clean this right now. While working on a chassis, I recommend you retract the tuning condenser or capacitor all the way so that the plates don't get bent. This particular radio is has a plate on the bottom, so we can undo that now. Okay, here is the bottom of the chassis. So let's kind of identify what all this is here. Let me zoom in a touch here. So we'll go from top to bottom. We're gonna go over just a couple basic things. Here's our filter capacitor made by Pyramid. After rectification of the incoming voltage, this further smooths the signal so that there's not additional noise going through the radio circuit. These are various capacitors. Some of them are coupling caps, some of them are ground caps. They serve various functions. Here we have one of the coils. I believe this may be the oscillator coil. It's the audio output transformer, some various resistors, the on-off switch, and volume potentiometer. And yeah, so this is a series strung set. That means all the tube filaments are going to be wired in series or together. That means it's not a transformer. Often a transformer set, that is going to step down the voltage to a voltage that each of the individual tubes use, and it will individually supply it to each of the tubes, while this runs through line cord, filament, whatever, and then back out to complete the circuit. And that's what this has. These are going to be slightly lower voltage tubes than a 5-tube set because all the tube filament rated voltages need to add up to usually 110 volts. Alright, with that out of the way, we are going to do a first power up. So in a video soon, I need to build a dim bulb tester because it's kind of obnoxious. If there's any shorts, I'm kind of screwed. But what we are going to use is a isolation transformer and a variac. So if you look at this, this is an isolation transformer. This is going to basically isolate you from, I believe, the hot side of the AC line, so that even on a series strung chassis where the neutral or hot goes to ground, you're not going to get a shock. And this is a variac. This will just, you can control the AC voltage going into your load. So we're going to bring this up slowly. Inrush power is bad for old electronics. So we are going to plug this in. I'm gonna see if I can eventually get 2 cameras on this, but right now I'm not. But I'll tell you what I'm doing. So I plugged it into the isolation transformer and variac. We're gonna turn this on. Obviously it's gonna do nothing since this is off. So we're gonna turn this on. I'm gonna slowly bring this up to about 60 volts. Remember, this is with all the original electronics. Even if it works, I would not leave this plugged in for very long. So we're on. Some radios respond at 60 volts, some don't. Remember, normal line operating voltage, at least for these, was 110. More modern AC runs at 120, 125 volts. But, yeah. I'm going to bring this up to, what is that? It's going to be like 80 volts. And that's a bit odd. We should start to see filaments at about this voltage. And here you go. Probably a cutoff circuit. At 80 volts, we're getting hum. When it's not impacted by the volume control. I'm going to quickly bring this up to 110 volts. See, it just gets louder. and we're going to turn this off. So this tells us a lot. Hum, there's a low hum, you can't really control it with the volume control. Almost always, this means bad filter capacitors. If we go back to what I was saying a little bit earlier, and remember that they further filter out the dirty AC signal, because remember, trying to rectify it and smooth it into ideally a perfect DC signal. If there's any variance, because remember AC represents a sinusoidal wave, that is going to cause noise in the audio circuit, and that means the filter capacitors have failed. So we are going to replace the filter capacitors, and let me talk to you a bit about capacitors here. So I'm going to pull out two different caps here, and we're going to talk about the differences here. Alright, so we have two different caps here. This is a non-polarized capacitor, and this is a polarized electrolytic capacitor. You're going to want to use these for filter caps and these for other normal tubular wax caps. So this actually has a polarity. If you stick it in backwards, it's not going to work as intended. These often blow up if you stick them in backwards. These technically have a polarity, an outside foil. I wouldn't worry about it too much unless you're working on high-end audio. But if you really value that, you can use an oscilloscope to test the polarity. There's many great videos on YouTube. I'll let you look that up yourself. You're going to want to use these for the filter capacitors. So we're going to look for any useful information on this. So we're going to see if we can pull this out from the radio a bit. Pyramid Electric Company, okay. This is what you want to look for, these numbers. So let's take a look at these numbers. We see 30 and 50. Is that it? Yes, a 3-lead cap. So we have 30 microfarads and 50 microfarads at 150 volts. Those numbers will still correspond to modern capacitors. So if you're looking for replacements, you want your microfarad value, that's your capacitance, and rated voltage, that's your voltage rating. And then we have black, common, negative. So how do these work? Because we saw that capacitor a minute ago that had 2 leads going out of it. This has 3. So what is going to happen? I consult schematic. You should get the schematic of your radio. But in general, these capacitors are wired so that all the negatives are wired together. So let's see. We have a 30 at 150 and a 50 at 150. So we'll get a 33 at 250. You can always go up on the voltage and up to a certain extent on the capacitance. Don't go down on either. And then we have 47 at 250. Yeah. So how does this actually work? How can we get 3 leads from this? So we can see we have a stripe on one side of the capacitor. That marks our negative for both. Sometimes it marks the positive. Check the manufacturer, check the data sheet, whatever. So how this is actually going to work if we open the leads here? These negatives are going to be tied together like so. And like this. So here we have the positive of the 50, and here we have the positive of the 30. And we have the common negative, and we saw it written as that on the capacitor. So we're going to solder these in. These are new leads. You can tin them if you want, but I don't tin these. All I'm doing here is just soldering them. So you're going to wait for the soldering gun to heat up. Done. And we're just going to tin these leads. It's kind of hard to do this in front of a camera, who would think? And I have to keep my distance, that's fine. I'm going to pick this up a little bit. Come on. And there you go, that's soldered. Just pinch these closed. Like that. And looks a little bit better. Because you know how people on YouTube be. Your soldering's ugly. So now, we'll just glue them in and let's test them. Alright, I managed to glue these filter capacitors back in. So now we're going to test the radio again. Test and check. That's the name of the game. So let's plug this in to the isolation transformer. We'll turn the switch on. Obviously nothing's going to happen since there's no voltage going in. We're going to turn the isolation transformer and bring it up to about 60 volts. We should begin to see some filaments. So now we're going to bring this up to 90 volts. And I can see the audio output tube glowing a bit, along with some of the miniature tubes. And something's coming from the speaker. This up all the way. Alright. So unfortunately this tube socket is still giving some problems. Some problems of, intermittencies and such. But we are going to move on. We'll keep an eye on this. I have a replacement tube socket if needed. It looks like one of the pins is bent out of shape, but the problem is quite intermittent. So now we've replaced the electrolytics, let's go on to replacing the wax capacitors. So we'll go with this pretty easy to get to one right here. Now I'm not going to go over, how to do this, because there's other great channels on YouTube that can explain this better than me, and I've also done some videos on basics in restoration. But we'll go over, the basic process without too much of the theory and strict process here. So we'll work on this one right here. So how I would do this is I'm going to cut this lead, the least disturbance to the circuit. So instead of cutting all these wires to keep the lead intact on the cap, and just cut the lead, and I'm going to mark where we cut the lead with a little alligator clip, just so that we know the functional connections of the capacitor. And then I am going to go ahead and snip the other side. And this is on this shrink, so we're going to take it off. Pop off a little bit. This isn't like the pure plastic stuff that cracks into a million pieces. This is still structurally just fine, so we'll leave that here, but we will put the clip on here so that if you're called off to do something else or whatever it may be, you can go back and say, okay, this is where my capacitor was connected. Now, some people take note of the polarity. While these are technically non-polarized capacitors, they do have a sort of polarity where one lead is hooked to the outside foil. Remember, a capacitor, it's a dielectric device. It has a metal foil and a insulator, which are both in a sheet-like material, at least in these types, that are rolled up. This creates a capacitive device. And now one lead is going to be going to the middle of that roll, connecting to the sheet, and one lead is going to be going to the outside of the roll, connecting to the sheet. The outside is obviously, since it's in more of a direct path from interference, it's going to be more subjective to interference and noise, which may be undesirable. This is a basic circuit. It doesn't matter too much, but I think it is important to acknowledge that some people take note of that, and using an oscilloscope and touching the capacitor. Mr. Carlson has a great video on this. I'll probably link it in
you can determine which end is the outside foil, per se, like I was saying. Anyway, we're going to read this. 0.05 microfarads at 400 volts. I'd stay within 10% tolerance of the capacitance, and as long as you're at the voltage or higher, you're okay. When you get to super high voltage stuff, you know, that's not good, but, you know, in general, it really doesn't matter. I worked on a Fisher 400 a while ago. That is a $1,200 amplifier. Yes, I marked the outside foil on all the caps, and I bought special caps. Whatever. You know, is that audio foolery? Who knows? Although the caps I did get had much less interference when I measured them on the oscilloscope. So we can see 630V. Great, and our code is 473. We can read. I should really just learn it. But 473 is 0.047. That is close. That is certainly in tolerance to the 0.05 that we have here. So we're going to bend these leads outwards. We have our soldering gun and our solder. Always make a mechanical connection. You don't want to have your stuff held on purely by solder. Otherwise, you know, otherwise it's not going to stick if the solder joint is a cold joint, or, you know, the temperature fluctuates and bad things happen. This wire was loose. This was not soldered in bright. That is a great example of a cold solder joint. So we'll do the same on this side, hopefully with less hassle, although knowing my luck. And, you know, this ain't OSHA approved, or more like UL approved, but, you know, you could put an insulator here, but it's not going to touch anything. Now, since this radio isn't a part of my house, I'm going to tighten these screws up. Since this radio isn't a part of my house, UL can't touch me. There's so much of a curve of what you can do when restoring radios. You can, you know, do the minimum. You can do a resurrection. You don't even need to do a restoration. Or you can really, really take that radio apart, learn how it works. It'll actually take forever, but if that's how you like it, then that's alright. Alright, then after every cap, or every couple caps, because we all get lazy, you should test the radio. 60 volts, 90 volts, you know, bring it up on the variac. After you know that first power up, or after you've done something like heinous, you can bring it up slowly, but, you know, with this I just bring it up pretty fast. I mean, you know, check for tube filaments and all that. You know, replaced it with a functionally equivalent component, so it should work the same, except obviously this one's going to be more in value, in tolerance, with our Unicon.
It really set him down. There needs to be some mentorship there. That's the thing I sort of wondered, because you look at that offense and it's, you know, they have no depth at receiver whatsoever. You see that Vikings run?
Them to tear down the American flag, the DC flag, and
whoa,
the flag
my battery charger.
They burnt the American flag, and then on the flag poles where the American.
Okay, so you got the technique. So off camera, I'm going to do the rest of these capacitors, test them out. Oh, and then after the radio, after you turn off, don't be an idiot. And, you know, short these caps out because they hold charge. They're capacitive, so watch out. All right, I'm going to replace the rest of these. I'll be right back. Alright, another thing we're going to do real quick is clean the radio up. Alright, the finished radio looks very nice. I'm happy with it. And the chassis is clean, even though no one will ever see it. So, for our last test, I'm going to run this just into the wall. And the last thing I need to do, I'm going to do this obviously after the video has been published. I'm going to buy some 47 bulbs because the 44 is way too dim. And this originally had a 47 in it. And I don't even know why I got 44s. I think one radio I worked on, probably the 37630, used a 44. But they're the same, except the 47 is higher resistance, so it glows brighter.
I needed this course to play as hard as possible, and I needed was what we learned later, and that was members of his family, like his wife, Dr. Jill.
Well, I stepped out the tub, put my feet on the floor. I wrapped the towel around me and I opened it. And in a splish splash, I jumped back in the bath. Well, how was I to know there was a party going on? There was a splishing and a splash and breathing.